All right, y'all, so this is the next part of lesson 3.3. So this is absolute value transformation. So these are a little harder, and so I've got my own video on this one. So let's talk about this. So what this is saying is that we want to take the absolute value of a function. So if I asked you what's the absolute value of -5, you would tell me that it's 5, right? And so what we know is when we take the absolute value of something on the inside, then it's always a positive number, right? Doesn't matter. What we're looking at is the distance away from 0. So here we're saying the distance is negative, but we don't care about that. We just want to know, so we say it's positive. So when we see an absolute value function, what this means is that any negative y values become positive y values. So any negative y values become positive y values. So a better way to think about this is that the negative side, so negative y flips, so we use this word flips or reflects to the positive. So let's try one of these first. So we have this random function here, and it's not a specific function, it's completely random. So what we know is that when we have a positive number, that value is going to stay positive. So if I look at this graph, this is 1, 2, 3, 4. This is 4, so I can go over here to 4, and then I can go to this point here, and I can go to this point here, and this part of my graph is all a positive y value. So let's look at this again. Negative y values become positive y values. So what I've graphed is just this part of my graph. Now I can go over here and I can look at this part of my graph. So 1, 2, 3, 4. And this point here, and this part is also a positive y value. Now, I'm going to switch this up a little bit because this is all negative. It's all below the y-axis. So I have negative y values, and these are all negative y values, and they need to be positive. So when I have, that's this part, a negative y, we're going to reflect it to be positive. So this point right here, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. This point is -6, -4. So if I want to make this positive, I'm going to go over here to +6, +4. So this point is now on the positive y side. And it's going to go and meet up with that. Okay? I can find this point right here, 1, 2, 3. So this point is 3, -2. So I need this to be positive. So I'm going to go 3, +2. 1, 2, 3. So I'm connecting here to these points. So I go to this and to this. And so this is what my f of x, absolute value of f of x graph looks like. Everything is positive. Positive y. Okay? So now let's look at this one. This one's a little different. This says only the x values are positive. So if I have this f of x here, so my negative x values don't exist. I don't have negative x values because I can't take negative absolute value of x. But I still have graph, so what does that look like? That means that the positive y values, so positive, oh, I said y, I meant x. Positive x values are reflected or flip over the y-axis. So negative x don't exist, so the positive x values are reflected. So I know that this positive x, nothing's going to change. So I'm going to put these points over here, and I go here, and then I go here, and here. So those values are all the same. These are my positive x values, which makes sense because it's the absolute value of the positive. So now what happens is I am going to reflect over y. So I'm going to take these same points and I'm going to put them on this side. So this is 1, 2, 3. So I'm going to go here, and then I go up 1, and then 1 and 2. So this graph now on the left side mirrors what I have on the right side. So that's what happens when we flip this way. Okay. So here we have a parent function. So this is a quadratic. So I have a quadratic function. My quadratic function is going to look like this, right? But what happens is I have a new vertex. So this tells me I'm going to move right 2 and down 3. So I move right 2 and down 3. And I know that my parent functions, I'm going to go up 1, and I'm going to make this look like a nice U. And that's what that function, transformed function, is going to look like. So now I see that I have my entire function on the inside of the absolute value bars. So if the entire function's on the inside of the absolute value bars, this means I only want positive y values. Okay, everything has to be a positive y value. So if I look at this right away, I know that when I get to this part, I'm going to be above the axis, and when I get to this part, I'm going to be above the axis, right? So if I'm looking at what's positive, this part's positive and this part's positive. This is all negative. This is what has to switch. So if I have this point at 2, negative 3, it now becomes 2, positive 3. And then I would go down 1 and down 1, and so here is what my parabola looks like. So this part that was negative, all down here, now becomes positive. Okay, so one more thing. So now we've got this part of my graph. So this part of my graph says that anything, we only keep positive x. So if I only have positive x, then what's going to happen, and I didn't really show this graph here cross over very well, but let's just say that it crosses here at, and I don't really care where it crosses, but let's just say it crosses here. I have this point still at 2, negative 3, and I have this point and this point, so this is what I have. That part stays, but now I have to mirror this over my y-axis. So this part is still 2, negative 3, up 1, but it's going to look like this now. So I took this and I mirrored it over. Okay, let's try another one. Okay, so we know what this is. We know that this is my x cubed function. So my x cubed function would look like this, my normal parent function. But this tells me that it's negative, so my parent function would look like this. Okay? The only thing that makes this different is that I'm going to move the whole thing up by 1. So instead of going through the origin, it's going to go through this point, and this point, and this point. Okay? So my graph is going to look like this. It's going to even out here and flatten out, and then it's going to come down this way. So that's what that transformed function looks like. Now with this one, I only want positive y values. So if I look at my positive y values, what happens on this is it stays positive y until it gets to this point right here. So I'm going to keep these points. It's going to even out. It's going to come here. And then when I hit here, this part that's negative is now going to flip up, and so it's going to look like this. It went down, and now it's going to come up. So we have this shape that's right in here that looks like my cubic function, but this negative part now becomes positive. Okay, one more. So I have this one. This tells me that I want only positive x. So if I only want positive x, I only care about what happens on this side. Well, what happens on this side, I have this point right here, and this point right here, so I know that this is evened out, and then it's going to come down this way. Oop, that's not very good. And so now I'm going to take this and I'm going to reflect it on the other side. So if I reflect it on the other side, it's going to look like this. So it kind of looks like a parabola. Remember, my normal function, if I was to sketch this out, would be through this point 1, 1. So it would be like this, and then even out, and then come down. And so it's not a parabola, but it kind of does look like one. Okay, let me, here we go. I knew I had another paper. Ooh, lightning. Okay, so now we have ln function. So I have an ln function, and this tells me that I have a new asymptote, and this asymptote happens at -2. So I have this asymptote here. Remember, for an ln function, this asymptote happens, this is a shift of my asymptote to the left. Okay, so my log function looks like this, right? But what I have is I have this point at +1, so instead of starting at 0, 0, or starting on the x-axis, I'm going to move up 1 point. So this is my starting point. So my graph is going to look like this. Okay, approach my asymptote and I move away this way. Okay, so going back to what we know, this is the whole thing. So here I only want the positive y values. So if I want the positive y values, my asymptote here is going to stay the same. Okay, and I know that my y values, clear till I get to this point, so I keep this point 1, 1, this part, nothing changes. That all stays the same. But this, as I approach my asymptote here, now I'm going to flip that up, and it's going to go this direction. And it's still going to approach the asymptote. It's just going to approach the asymptote on the positive y side. Okay. Here, I only want to keep positive x. Only the x is here. So, what I know is if I only want positive x values, if I cross here at about 2, and again, this point is not important. This point is, right? That's a known point. This point is not so important, but this is what I care about. So this is the part of my parent function that is positive x. So if this is positive x, then what's going to happen over here is the other side of this is going to go this direction. So this doesn't look anything like a logarithmic function, right? So super important, you get your basic parent function, and then we're going to go opposite. And so here, it doesn't matter, the asymptote's gone because there's no asymptote in my positive x. All right, let's look at this last one. This last one's a little bit tricky. So I have here an asymptote that happens at -1. So this, again, is my horizontal asymptote. So that guy's there. I have a positive asymptote at 2. So here's my vertical asymptote. So what I know is that this is my starting point. So here is where my first point is, and here is where my second point is. And so this graph is going to look like this. So horizontal asymptote at -1, vertical asymptote at +2. Okay? Now, again, this tells me that I only want positive y values. So if I only want positive y values, then my vertical asymptote is going to stay the same. But what I have here is that my horizontal asymptote, this asymptote is negative. So I'm going to flip this asymptote over my axis because I need this asymptote to now be a mirror image of the positive side. So it's going to be on the positive side. So if I look at my graph, what I have on this side of my graph is going to look like this. 3. Okay, now I know what you say. You're like, okay, hold on, because you passed over this asymptote. But I can do that because this was positive just on my normal parent function. So I know I'm crossing over it. I need it for the next part, but that's okay because it was already positive. I didn't modify anything. Now, this part that goes negative, when I flip it above the x-axis, the x-axis, it's going to look like this. And what I have down here is that all of this is negative. So if this is my new starting point, then this becomes the other part of my negative part of my function. So that is going to look like this. So very different. Very, very different. Okay, last one, and we're done. And I know these are challenging. I know you're going to probably want to come in and see me. So here we only care about what's happening on the positive x side. So positive x side, that asymptote can stay. And -1, this asymptote can stay. I don't care about what's happening over here right now, right? So if I only care about what's on this side, well, this part doesn't change. This was all positive x. So this part of my graph stays the same, right? And I have this point right here. And this part of my graph stays the same. Okay, so think about it. If I only care about positive x, if I cover this up, this part of my graph models what I have over here exactly. Now, this is pretty cool. If you think about, and I'm just going to put it back in here. So here was my asymptote, and when we were looking at the absolute value of the whole function, what we did is we redid our asymptote. Well, here, I'm going to do the same thing when I reflect it. So this asymptote comes back here at -2. And here's why. Because if I'm going to take this side, I'm going to take this positive x side, and I'm going to reflect it over y, that means this part is going to reflect. So it's going to look like this. But this part is also going to reflect. So it's going to look like that. So this one, number 10 here, is super, super challenging, but hopefully what you see is if you draw your parent function and you say, okay, I only care on this one, I only care about what's positive, and then I'm going to flip everything up. With this one, I only care when x is positive, and I'm going to flip everything over. Okay? All right, come see me, and I'll give you some examples of these.